Okay, class, we are going to do a factoring review. So we're going to start off by factoring the quadratic shown in number 1. So to do this, we're going to factor with the box method. So if you haven't seen this before, I'm going to go ahead and show you how to do it. We're going to want to find two numbers that add to be negative 2x and multiplied to be the product of those outer two numbers, which is negative 48x squared. So it's negative 48x squared. So I need to think of the factors of 48 and think of the ones that add to be negative 2x and multiply to be 48x squared. Well, I know that 6x times negative 8x gives me negative 48x squared. And if I add 6x and minus 8x, I get negative 2x squared. So I'm going to take these two numbers, the 6x and the negative 8x, and put it into these two boxes. It doesn't matter which you put where, you can put it either way. So 6x and negative 8x are my two. And then I'm always going to take the first number and put it in the first box. I'm always going to take my last number and put it in the last box. So I have negative 48 there. Now I'm going to pull out the greatest common factor, the GCF, out of each row. So this first row, they both have an x in common. The second row, they both have a 6 in common. Pulling out the GCFs. And look at the first column, they both have an x. And then the second column, they both have an 8 in it. And in general, always, if this number is negative or this number is negative, you pull out the negative sign with it. So we're going to pull out a negative because the closest one is a negative. For this one, we're going to pull out a positive because that was a positive number. And I'm going to check x times x gives me x squared. X times negative 8x gives me negative 8x squared. X times 6 is 6x, and x times negative 8 is negative 48. So this quadratic factors to x minus 8 times a factor x plus 6. And you can FOIL this using the FOIL method or the box method to confirm it. So let's use the same method for number 2. I want two numbers that add to be a negative 4y and multiply to be the product of the outer two, negative 12y squared. So think of the numbers that multiply to be negative 12y, and you can see that negative 6y and 2y multiply to be that and add to be what we want. So 6y and 2y are what we want. So you can put them in either order in the diagonal. Put the first number in the first box and the last number, including the negative, in the last box. Pull out your GCF. There's a 2 and a y in the first row, so I'm pulling out a 2y. And there's nothing in common in the second row, so the GCF is 1. The next column with the 4y squared and the 2y, I can pull out a 2y. And the last one, the sign is negative, so I'm going to pull out a negative, and they both have a 3. And confirm 2y times 2y is 4y squared. 2y times negative 3, negative 6y. 2y times 1 is 2y, and 1 times negative 3 is negative 3. So factors as 2y minus 3 times 2y plus 1. So those are my two factors. And I could have written the two factors in the reverse order as well. Okay, next one is when you have special patterns. So there's two special patterns. You can always use the box method for factoring, but you may notice that you have perfect squares, trinomial, or the difference of two squares. So to use the first one is if you have a perfect square and you're subtracting, then they factor as the square root of the first, square root of the second, 1 plus, 1 minus. So I notice this is a perfect square, and that's a perfect square, and it's a difference of perfect squares. So it factors. You take the square root of your 16a squared, and that is your first term, which is 4a. And you make 1 plus and 1 minus. And you take the square root of your 225, and that's your last number, and the square root of 225 is 15. So it becomes 4a plus 15 and 4a minus 15. You could sit there, okay, two numbers, if you want to use the box method, that add to be the middle number, which is in this case 0a, and two numbers that multiply to be 16 times 225. I don't want to do that arithmetic. So this is where the box method would work, but it's more cumbersome. So we can use the box method for the next one. We want two numbers that add to be negative 12z, or two numbers that multiply to be the product of the first and the last number, which would be 36z squared. And I know that negative 6z and a positive 6z works. That's a z squared. That's a scribble there. Okay, so that says 36z squared. Sorry about my bad penmanship. So we could put this into the box. So I would put a 4z here, and the 9 there. Negative 6z goes in the negative 6z here. So they're each negative, because a negative 6z times a negative 6z gives me a positive 36, and a negative 6z plus a negative 6z gives me a negative. And you can pull out your GCF, which is a 2z, a negative 3, a 2z, and a negative 3. And so it factors as 2z minus 3 squared, because it's just a repeat. Okay, so we can factor using the box method, no big deal. But we can also factor using the perfect square trinomials, which is the second one here. So if you have a perfect square and a perfect square, and the middle number is twice the square roots. So let's look at it here. That's a perfect square. That number is 2z squared, and the 9 is 3 squared. And this middle number, negative 12z, is negative 2 times the square root number 2z times the other square root number 3. It is negative 2 times 2 is negative 4 times 3 is negative 12. So it is in fact following that pattern. So it factors as you take the square root of the first number and the square root of the last number. So the square root of the first number is 2z, and then the last number is 3. And if it's plus in the problem over there, then it's plus in the answer. If it's minus here, it's going to be minus here, and then it's squared. So you can do it two ways. You can remember the special patterns and do it that way, or you can use the box method. Okay, so next one, we're going to go ahead and factor this. If you see that it's a special pattern, you can use a special pattern. Otherwise, you can use the box. I see that this first number is 6w squared, and the last number is 5 squared. Now the question is this middle number twice those square roots? Is it 2 times 6w times 5? Is that what 60 equals? 2 times 6 is 12 times 5. That's 60w. So it is. So it factors. You take this first square root number, you take that sign, which is plus, you take the second square root number, which is 5, and square it. And that is how you factor it. Okay, so the next one, you must notice that it has a GCF that can pull out, and you must always pull out the GCF before you factor. So it's 2 times 7x plus x minus 3. Okay, so this isn't a perfect square. Oops, it should say x squared though. It's not a perfect square, so it's not going to be a special pattern. So we're just going to find two numbers that add to be the middle number and multiply to be the outer numbers, negative 21x squared. And the numbers, 2 times 3 is not 12. It should be 2 times 6. Again, it's still not a special pattern, but we want numbers that multiply to be 7x squared times 6. And so the numbers that multiply to be negative 42x squared. And the numbers that multiply to be 42 are 7 and 6. So 7x and negative 6x becomes negative 42, and they also add to be a positive 1x. So I'm going to put my 7x and my negative 6x in my box. My first number, 7x squared, goes in the first box, and my negative 6 goes in the last box, and you pull out the GCF. First row, they have a 7x in common. Next row, they have a minus 6. First column, they just have an x in common. The next, they just have a 1 in common. So this 2 comes down for the ride, and then I have x plus 1 times 7x minus 6. And that is how it factors. That's a 1. Okay, let's go on to the next problem. So I see that there's a GCF. The GCF that I can pull out is 3v. So using the distributive property, after I pull out a 3v, I'm left with v inside the parentheses, minus 6 when I distribute it through. There's no more v squareds. This is factored as much as possible. So I'm done with that. Next one up, it's not a perfect square trinomial, but I do see that they all have a 3 in it. So I'm going to pull out the GCF of a 3, and I'm left with 4x squared plus 1x plus 1. And I'm going to see numbers that multiply to be the product of the outer two, which is 4x squared, and add to be the middle number, which is x. Well, the numbers that multiply to be 4 are 4 and 1 or 2 and 2. Neither of which sum to be x. So this tells me that you cannot factor it with these methods. So it's not factorable. And sometimes that happens, that things are not factorable.